about what they've been doing, and they've been doing a lot, and it's been a little dark, so I can re-explain what some of those things that they're doing. So the observation blocks are about an hour long, and the crew is organized. The 4 crew members are organized into 2 pairs of 2, the window team and the cabin team. And the lunar targeting package that you've been showing up and that the crew have on their handheld tablets is really the instructions for the window team. So the window team, the 2 crew members are looking out the window. One has the camera with the long lens. One has, they're just looking out the window with their unaided eye, and they're taking these detailed observations. And then halfway in that observation block, they do the window team position swap. So that's what Capcom's been calling out, and they'll switch positions. So each crew member has a chance to have that long lens. And then that's just what the window team is doing. There's also the cabin team, where they also have duties that they're doing. We're asking a lot of the crew in this time. And then the cabin team, they have the interior camera, and they're taking images inside the cabin. They're also supporting the window team, where, you've heard some call-outs where looking out at the bright moon and then looking inside the dark cabin and looking at their LED screen is a lot. So the cabin team is also helping support, target, and guide the window team into specific targets on their plan. They're also helping call out these science situational reps. So they're looking out a different window and listening in to what the crew who are really down and in the science on the window team are doing, and they're giving us insight. And those recordings that the window team is doing are going to be uplinked or downlinked overnight, and we're going to be able to chew on that data. But yeah, they're helping. They're doing a lot, and so making sure we have a plan that's flexible, but also make sure that we check off all those boxes was really important.
So tell me a little bit more. You talked earlier about the analogs that the crew has done. What kind of analogs or environments were really useful for this?
Yeah, so for procedure development, right, you have so many different environments that you can do. You have classroom, like we said, you have the Orion mock-up, you have simulations, and at least for developing the plan, we kind of did it in a tiered approach, because each of those different analog environments helps us answer a slightly different question and has a little bit of a higher fidelity. So we would start with the classroom. So we would we would just get into a classroom, we would put all the hardware on the table, and then we'd almost role play of like, you be Victor, you be Reed, you be Jeremy, and I'll be Christina, and let's just do the plan how we think we should do it. Write that down, and then just keep iterating on that, and then
Integrity Houston for a tag up pre-forward link LOS in place of the Flight Director Conference.
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics here. The first 2 are for timeline. First of all, read for your toilet maintenance. It is a shortened toilet maintenance where you do not have to do the oxone changeout. That portion of the procedure is canceled. Victor, you have an HHP stop activity on your timeline. We need you to perform that as scheduled for bandwidth reasons. For your next portion of the flyby, in particular the eclipse, we want to remind you that you can take off the eclipse glasses when the sun sets and you are simply looking at the corona. And then finally, for the D5 with the long or zoom lens, which is set for solar corona, we want to remind you that when you are capturing Earth shine, you will likely have to adjust the exposure. That's all I have for you. Let me know if you have anything for us.
Okay, Houston, we copy all. Thanks for those words, Jenny.
All right, just a quick call up to the crew ahead of a forward link LOS, meaning that we won't be communicating with them, but we will be receiving their communications and data during that time frame. So, Angela, we were talking about analog environments. You were telling me about the classroom and getting in there and pretending who's Victor, who's Reed. Tell me more about this.
Yeah, it works pretty well. So you're gonna do the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it and then they'll be like, these steps don't make sense, and we'll reiterate on it over and over. Then we'll take it to a higher fidelity environment like the Orion mockup, and we'll do the same thing because that volume is smaller, the window placement, their seating, what things have we forgotten with this addition of this environment. And then once we reiterate on that, we'll take it then, we'll give it to the crew and have them execute off of it during mission simulations. That's the highest fidelity that we can do before we send it to space. So this is the first time we've had to do this because we're a brand new console, and it just sparks so many neurons of like, how are we going to do this for surface missions and integrate this in so many different ways. So excited to have kicked off this process, but there's so much more to come.
Fascinating. And I think it was really well thought out too, because each crew member gets an opportunity to do each task. And so you're getting different perspectives and different insights from each crew member, maybe even about the same target, but something that one person sees could be completely different than something another person notices. So we also know that Artemis 2 has traveled. They're now on their way home, but they traveled farther from the moon than the Apollo missions did. So what makes that vantage point scientifically interesting?
Yeah, observations are so fundamental in the scientific toolkit, particularly observations from different perspectives, different scales, and with different techniques. And so we really tried to make the plan to optimize those. There's pros and cons for all those things for this mission. So we really just focused the plan to have all those pros. So in terms of scale, this zoomed out scale, you can learn different things. This different perspectives. So their perspective, as Kelsey talked about, photometry around when they orbit the moon. And then also just their different the different things they're able to observe. Let me talk a little bit about scale, because I think observations at different scales, you can gain a lot of different information. So like, for example, if you were an astronaut on the surface looking at a rock, and you describe at this micro scale. So in training, we kind of talk about observations from micro to macro, or from outcrop to orbit. So looking at a rock at this scale, you can describe its components, you can describe what it's made of and its colors and its minerals, and you're like, okay, and this rock came from this boulder, and it's this part of this boulder, and these are the different things that I'm observing around. It gives me context to the sample, and then you zoom out a little bit more, and you're like, okay, well, I can see that this boulder came from, it rolled from this mountain ridge, or this high ridge feature. And then because I can see the trail that it came from, okay, now let me describe this ridge, and different parts in it, and maybe other boulders that I'm seeing. And then you zoom out further of the orbit scale, and you're like, this ridge is a part of this larger crater. So all of those different steps give you different information, and so that's why observations at these different scales and these different perspectives are so important. So this zoomed out kind of far view is this full lunar disk view. It's the full lunar, on Earth we see the full lunar disk as well, but now we're able to see it on the far side, and we're able to see it all at the same time, which enables the astronauts to compare very quickly to different parts of the surface. And the color particularly is very compelling, because you can just be able to very quickly compare from 3 different regions. Is it in the same family? Is this actually a little bit different? Compare that to what they see in their orbital data that they have access to on their portable computers, and really just be able to tease out that nuance and information.
Yeah, we heard them make a lot of those connections today, and especially the color. We talked with Kelsey about this a little bit, just how exciting it was to hear the browns and greens and things like that. I cannot wait to see those pictures. So one last question. We are coming up on the last lunar flyby observation block, and this is when we are going into a solar eclipse. So can you tell me what you're interested in the crew learning during that time frame?
Yeah, so the data set So yes, there's so many things. How to pick one. So I'd say the thing that I'm most interested in seeing is some of their annotations that they're taking. So in this opportunity, it's a very dynamic type of experience in that we don't normally see this activity, and so being able to have crew observe the solar corona and then also annotate it in their on their portable computing device is just such a unique thing that humans can give to missions, and also particularly being able to annotate what they're observing while they're talking about it is also unique to being able to have astronauts in orbit as well, because we won't be able to have annotations on the lunar surface because the astronauts will be in suits. They're going to be collecting samples, they're going to be deploying instruments, and so personally, I'm really excited to see some of these annotations and to see how that develops over time, because you've heard a lot of descriptions, and I think when people are describing something that's unique and different, you can interpret it differently. But if you're drawing and you're marking, particularly just going back to like the color provinces, for example, and those boundaries, you know exactly what they meant. And really, I'm just very excited about those annotations. There's been some famous annotations that the Apollo crew have made, particularly about solar coronas and the structures and lofted dust that have given a lot of debate within the scientific community of they're observing this phenomenon, and now it's our job to hypothesize of like why are they observing this, like what is going on. So I think that's just a really cool part of exploration and science, and this beautiful thing that we're about to do.
Well, now you've got me excited about the annotations too. I mean, I've been excited about the pictures and the audio, but now
don't sleep on the annotations. I am very excited to see these little sketches that they're able to draw out, and we have pictures that they can just draw right on. It's like this particular thing is different than what we've seen, so I'm excited about that.
I'm excited too. Angela Garcia, thank you so much for joining us today, and have a great time tonight on Console.
Thank you, and you've been doing a great job, and it's so excited to see where we go from here.
Thank you so much.
Integrity Houston, you have 3 minutes until we go into a forward link LOS. We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.
We are live in Artemis Mission Control at Johnson Space Center in Houston, Texas. This a live view from the Orion spacecraft with our Artemis 2 crew inside. That's Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. We are still live for our lunar flyby coverage. The crew is in a short break while the spacecraft is pivoted away from the moon. We are going to be going into a solar eclipse. This is the first time anyone has ever seen a solar eclipse from the moon. So it's going to be a unique vantage point for our crew. But ahead of heading into that solar eclipse, we need to charge the batteries on the Orion spacecraft. Therefore, we have positioned the solar arrays into the sunlight to allow time for those batteries to charge. We will get back pointed at the moon just in time for that solar eclipse. We are also in a forward link LOS. What that means is essentially we cannot send calls or commands to the crew right now from the ground. However, we clearly get all of their data and communications. The spacecraft is now 4,632 miles away from the moon, and that number will only continue to grow as the distance from Earth shrinks, now 252,523 miles away. Our closest approach to the moon today was approximately 4,067 statute miles in altitude. Our maximum distance from the Earth is suspected to be 252,756 statute miles. Both of those moments came while Orion was flying in their loss of signal time frame behind the moon. The crew also set that new record today, beating the Apollo 13 record of distance from Earth. This is an animation or a visualization that you can track anytime, day or night, by visiting nasa.gov/track-Artemis. This shows you how the spacecraft is positioned as well as their distance and velocity, now traveling 930 miles per hour. During this break in their time today, the crew is working on a couple of other tasks. Some of those include their National Geographic timeline test. National Geographic was selected through a competitive process by NASA to help tell the story of Artemis 2. So you've seen the crew with some GoPros inside the cabin, taking videos and pictures, and with other cameras as well. National Geographic plans to leverage its portfolio of media assets, including magazines, social and digital content, and television programming for engagement opportunities. Throughout the flight, the crew has been timelined a little bit each day to film from a shot list provided by National Geographic, and that includes their morning routine, talking with their families, exercising, and just their overall thoughts about the mission. And I cannot wait to see that footage. Teams on the ground reporting that the spacecraft is looking good and that the power aboard is good as well, all setting us up in a proper position before eclipse. The crew is in a little break during our flyby coverage for today. They will resume their flyby momentarily in about 30 minutes once they get into their observations during that solar eclipse. Now, the moon is our nearest celestial neighbor, orbiting Earth at less than 250,000 miles on average. When our astronauts venture there for future Artemis missions, they'll target landing sites near the lunar South Pole. There, ancient rocks, minerals, and trapped water ice will not only provide resources for human explorers, but they may also contain clues to the formation and evolution of our planet and the solar system. Let's learn more about the lunar South Pole with this video featuring Dr. Kelsey Young, Artemis Science Flight Operations Lead.
We learned a lot from the Apollo samples, but we still have a lot left to learn about the moon. The Apollo missions visited only a pretty narrow swath of the moon. All the missions were concentrated near the near-side equator. Really interesting and really critical insights were unlocked with the Apollo samples, but we have so many questions still to answer about the moon and the evolution of the moon.
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
NASA's Artemis missions are NASA's plan to send people to the surface of the moon. We'll be sending people and roving assets and scientific equipment to, among other things, answer a lot of really compelling science questions. Scientists have a lot to learn about the moon. It's our nearest celestial neighbor here to Earth, so what the moon has experienced, we've experienced. Except here on Earth, we have things like plate tectonics, oceans, forests, people that erase the rock record. Whereas on the moon, that whole record of our planet's history, of the moon's history, is just kind of waiting there at the surface for us to explore. The South Pole, which is where Artemis missions are going to target, is specifically interesting for a couple key reasons. We think there are volatiles at the South Pole of the moon that are not present near the equator. Things like water and water ice that are trapped in the lunar regolith, which basically just means lunar soil, that can easily become untrapped from that lunar regolith, and scientists can scoop up and study for return to Earth. The lunar South Pole is a really exciting scientific target, and it also comes with some challenges for operating. For example, the lighting environment will change drastically within the course of one mission, and even over sometimes the course of one spacewalk. So preparing the crew members, preparing the hardware that we're sending to the moon, and preparing the mission control teams is really, really important. The South Pole Aitken Basin is particularly exciting. We think it's one of the oldest and largest impact basins in the solar system. And if we can get the right rock from the South Pole Aitken Basin and bring it back to our labs here on Earth, we can use that sample to constrain the entire evolution of our solar system and really understand the timing of how the moon and our planet and the entire solar system evolved.
You're looking at a live view aboard the Orion spacecraft of the Artemis II crew, working in the middle of one of their breaks, or really their only break today during this lunar flyby period. Coming up next will be that solar eclipse. Throughout the Artemis II mission, and of course throughout today, you've likely heard the crew being called with the name Integrity. The Artemis II crew members named their Orion spacecraft Integrity during a news conference September 24th, 2025. The name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. They said this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. The crew also said that integrity is rooted in a shared core value of NASA, the agency's astronaut office, and the CSA, the Canadian Space Agency. We are 5 days, 1 hour, and 38 minutes mission elapsed time into Artemis 2. In this view on the screen, you can see the crew starting to even look through some photos that they may have captured today. We really look forward to sharing these photos with you as soon as we possibly can. And the best way to keep up with those is to follow NASA on social media. You can do so at NASA, and for this mission specifically, at NASA Artemis. Again, we are in a forward link LOS, or forward link loss of signal with the crew, meaning that we're not able to communicate or send any commands to them right now as they were. This is a tracked event that occurs at times, but they could still provide communications down here to us, and we are obviously still receiving their video and their data.
Houston integrity in the blind. High priority PAO activities on Reed's timeline are on PCD1 in a folder imagery for downlink, and then high priority standby imagery for downlink, and then lunar flyby for PAO, and then high priority PAO. Thank you.
This is Artemis Mission Control. You heard Reed Wiseman, commander of the Artemis II mission aboard Orion, make a call in the blind. This means he knows we cannot call back and that he knows we may not receive his call. However, we have good communications with the spacecraft. They just cannot hear from us right now due to a forward link loss of signal. Again, we were tracking that this would occur, and we will regain that momentarily. But that call that came down from Wiseman mentioned some imagery, so we are very much looking forward to getting pictures taken from the moon today. Again, to see those images, make sure you follow NASA on our social media at NASA and at NASA Artemis. The view on your screen right now is an animation. This is called ARROW, or Artemis Real-Time Orbit website. You can visit this for yourself at nasa.gov/trackartemis, and you can watch as we continue to grow closer to Earth and farther away from the moon. It's all seemed to happen so fast so far, and we're coming up on splashdown now in 3 days, 23 hours and 31 minutes. This is Artemis Mission Control. We are in a forward link LOS with the spacecraft. We're not able to send commands or communications to them right now. However, they could send them to us, and we do get spacecraft data. This is tracked as we are on the Deep Space Network. This is the network that we use to communicate with the spacecraft now that we are so far from Earth, over 252,000 miles. We are still in our lunar flyby coverage. The crew still have a very important and very exciting flyby milestone coming up when they will see a solar eclipse from the moon, the first humans to ever do so. Something that we also have to consider when it comes to our missions and launches is space weather. So since the Apollo 16 and 17 missions, there were some solar eruptions near that time frame that could have been dangerous to our explorers. Over those 50 years since those storms, the data, technology, and resources available to NASA have improved, enabling advancements towards space weather forecasts and astronaut protection, which is key to NASA's Artemis program to return astronauts to the moon.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's Space Weather Program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
This is a live view from the Orion spacecraft on the Artemis II mission. It's now been 5 days, 1 hour, and 54 minutes since we launched. We are still in our flyby coverage, and the crew is on a short break right now as we have changed the attitude of the spacecraft to help charge the batteries aboard. We use the solar arrays to gather energy from the sun and store it in the batteries. That way, when we are not in the sunlight, we have those batteries to continue powering Orion. Now, we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts, it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. We're interested to learn if they see the outer corona when the sun is fully obscured by the moon. And because of how big the moon will be from their perspective, the total phase of the eclipse will last nearly an hour. The astronauts will see a partial solar eclipse as the moon covers and uncovers the sun, which is before and after totality. So, much like us on Earth, they will have eclipse glasses so they can safely view that portion. The astronauts will also be using cameras to capture images of the corona during the eclipse. There also may be some other planets visible during the eclipse, including Venus, Saturn, Mars, and Mercury. If they can identify what part of the sky they're looking at, this can help train future Artemis astronauts on what part of the sky they're seeing. This provides useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. Confirmation from teams here in the ground that we have reached the eclipse attitude, meaning Orion is in the proper position to observe it. The astronauts' break during this observation period is now over, and we are resuming their lunar flyby observations. The first of these is sunset. This is the solar corona that we'll be looking for. It's the outer atmosphere of the sun. The science team is also interested in if the astronauts can see polar plumes. These are thin streamers that project from the sun's north and south poles. Additionally, they're interested in seeing if the crew can witness coronal loops. These are arcs close to the sun's surface. And something else that we've previously mentioned is lunar dust. This is dust from the moon that is lofted above the lunar surface and illuminated by the sun. It was reported visible by Apollo astronauts. You're getting a live look from Orion as the crew observes a solar eclipse from the moon. Again, this solar eclipse is only visible to the crew on the spacecraft. It's not visible to anybody on Earth. The science team is interested in several different targets for them during this time frame. And we're personally looking forward to getting those images as well. Again, during the beginning portion of this eclipse, the astronauts will need to use eclipse glasses just like we do from Earth to safely view it. Once the moon has completely covered the sun, they'll be able to take off those glasses for almost an hour. Totality on Earth during a solar eclipse lasts only a couple of minutes. So this opportunity gives them a chance to look out into deep space and to look into see if there are other planets nearby. What you're seeing right now is the solar corona. That's the outer atmosphere of the sun. And the science team is very interested in any images that the crew can capture of this. They're hoping that they'll take pictures and describe the visibility, color, and shape of the solar corona as a whole and its substructures, those plumes and streamers.
Science, integrity, and the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon. You could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reed is in window 2 with the long lens, and Jeremy is describing it in window 3, and it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing.
Again, you're looking at a live view from the Orion spacecraft on the Artemis II mission. Orion is now 252,125 miles away from us all on Earth. We're here in the Artemis Mission Control Room in Houston, Texas, and what you had just before we lost that view quickly was the corona of the sun peeking around the moon as the astronauts are entering a solar eclipse for this portion of the lunar flyby. We're now over 5,500 statute miles from the moon. That closest approach today was just about 4,067 statute miles away. And teams in the room beginning to get a little busier and filter in and out as we are stepping through a handover. The Orbit 1 team is handing over to Orbit 2, who will continue monitoring lunar flyby and all of the systems aboard the Orion spacecraft. You're getting your last few views of the solar corona as the moon begins to take center stage and completely cover the sun. If you see that bright dot up near the top left of your screen, we think right now that that may be a part of the spacecraft, but we'll be sure to correct that if we end up figuring out later that it is something else entirely. It has been an absolute honor to join you here today for the lunar flyby of Artemis II, the first time humans have flown by the moon in over 50 years. I'm Leah Cheshire Mustachio, and I'm excited now to hand over the
team is shifting around in the windows, and we are transferring settings on a camera to pick up Earth shine. And it is amazing. The brightness where the corona, where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earth shine.
You know our rules that we don't talk when the crew is talking, so wanted to give Victor Glover a moment there to call down what he was seeing now that the moon is covering the sun. A really amazing time during today's lunar flyby. Again, thank you so much for letting us help tell this story today. I am Leah Cheshire Mustachio, handing it over to my friend Anna Schneider at the PAO console as the Orbit 2 team comes to join us. So thank you so much, and I hope you all enjoy tonight. Anna, you can take it away.
Thank you so much, Leah, and it's been a joy listening to your coverage over the last several hours. So as you mentioned, the Orbit 2 team of flight controllers is currently making their way on console and completing a shift handover with the Orbit 1 team of flight controllers. The Orbit 2 team tonight will be led by Flight Director Diane Daly, and she is currently handing over with the Orbit 1 flight director there on your screen, who was Flight Director Jeff Radigan. The Artemis 2 crew currently on board the Orion spacecraft. It continues to observe the eclipse that they are witnessing. There's about 43 minutes remaining in that eclipse period. This is Artemis Mission Control. You are currently seeing a live view of the solar array wing cameras on the Orion spacecraft. We spoke with our science team, and they did determine that that dot in the distance is Venus.
Science integrity. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
This is Artemis Mission Control. You were just hearing some communications called down from NASA astronaut Victor Glover, currently on board the Orion spacecraft. They are currently observing an eclipse. There's about 39 minutes remaining in that eclipse period. Currently, we are in a forward link LOS, or loss of signal, so the crew can communicate down with...
He's seen 2 meteors, science.
So we are in a forward link loss of signal. We do expect to regain signal in about 3 minutes, and at that point then the ground can communicate back up to the crew on board the Orion spacecraft. In the meantime, the crew can continue to communicate down to the ground. The ground is just unable to respond, so they are continuing to provide some science observations during this eclipse period. They've made some comments about Earth shine, which is the sunlight reflected from Earth when they come around towards the moon's near side late in this flyby window.
Science Integrity in the Blind. The glow around the moon is beginning to become a little bit more even. It's not so much distinct just where the sun set on the moon's horizon as we're flying through this trajectory, and then the sun's going to come up out of the other side. I think it's we're starting to see the glow around the moon get balanced out. I still see Earth shine, and the Earth is very bright out there. Still quite an unreal sight.
Integrity Houston, we have that sit rep loud and clear, and we are back with you. How do you hear me?
Hey Jenny, we have you loud and clear, thanks.
Copy. Victor, we're handing you over to Science for some critical questions. Thanks for your report. Integrity Science, we were loving your science sit reps in the blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reed observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reed, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
This is Artemis Mission Control. We have regained that signal, so the team here in Mission Control was able to call back up to the crew on board the Orion spacecraft as they continue their lunar flyby. Specifically, they are now in that eclipse period. So the science team here in Mission Control was able to ask some questions about some of the situational reports they were providing during that loss of signal. Specifically, they were interested in some of the meteors that they mentioned seeing and those impact flashes, and they did provide confirmation that they did see at least 4 impact flashes during that lost signal.
Are you still with us, Houston, or do we lose you?
Integrity, I hear you loud and clear. How do you hear me?
Okay, we got you loud and clear. One of the other things I wanted to describe, which was surprising to me, but the entire moon is lit up. It's glowing behind the entire moon. I thought it would look, dark against the black sky or deep space, but the sun is lighting up the entire limb of the moon. You can see the entire perimeter of it, and even now with the sun far behind the moon, you can still make out little bits of topography around the entire limb, just bumps as you go around it. And there's about the glow around the moon, once your eyes adjust, is easily 10 widths or diameters of the sun around the entire moon.
Incredible to hear, Jeremy. Were you able to actually pick out any discrete features on the lunar surface? And if so, how do they look different than when you observe them in solar illumination?
No, we really haven't been able to identify features on the lunar surface yet. We just see, the topography on the limb. For the Earth glow, we're about a quarter moon, waxing quarter moon, if you will, from the Earth glow perspective, and it's just at a very, just the sight angle. I'm just not able to tell what I'm looking at yet in the Earth glow.
Understood. Thanks, Jeremy. One other question for you on the solar corona. Were you actually able to see any structure or color in the corona before most of it disappeared behind the moon?
Yeah, I didn't pick out any color, but definitely structure. There were streamers, and they were not uniform at all. For me, the 5 o'clock position, there was just this constant streamer. It would change in intensity and diameter, but it was always there, and it was always at the 5 o'clock position. I only saw one plume, and it came out of basically the 3 o'clock position of the sun. That was very short-lived when I could see the plume.
Exactly what we were looking for. Thanks, Jeremy. And a heads up that we, calculated here on the ground about how long you could see the corona for, and we expect it to start to appear again in the next 11 minutes. Thanks for those amazing descriptions.
Okay, we're excited to see it all again.
Integrity Houston, we're following along as well. That was outstanding. If you haven't already, just reminding you to swap positions at the windows. And that brief LOS we had previously was due to a data rate change expected.
Okay, we copy that, Jenny.
Integrity Science, one more request for you. While it's still fresh in your mind, any annotations or sketches you want to make of what you're seeing either around the corona structures you just mentioned or even on Earthshine would be so appreciated.
Okay, Kelsey, it's going to be pretty hard to go look at a PCD right now, but we'll definitely try and annotate what we saw.
And if the annotations come in the next block where you're cleaning up your documentation, that sounds like a good plan to me.
This is Artemis Mission Control. On the bottom right corner of your screen, you can see a view of the Science Officer console here in Mission Control. And we've been hearing that communication between the Science Officer. The Orbit 1 Science Officer is Kelsey Young, and she's been asking questions to the crew, specifically CSA astronaut Jeremy Hansen, based on the observations they've been making during this eclipse period. And then in the upper left-hand corner of your screen, you can see a view of the Artemis Real-Time Orbit website, which provides updates on the velocity and the distance from Earth and the Moon of the Orion spacecraft as it continues to make its way back to Earth. The distance from the Moon will continue to increase at this point. So right now, Orion and its crew are about 6,300 miles away from the Moon and about 251,000 miles away from the Earth.
Okay, science, we're getting set up for sunrise. The window teams are, Christina is supporting, and also Xena in window 1. Jeremy's got the long lens in window 2, and the short lens in window 2. And Reed is in window 3, and he has started recordings and is set up to see Corona.
Great sit rep, Victor. That sounds like a good config, and we're showing coronal effects start to appear on your video camera. So in the next few minutes, we should start to hear your observations.
This is Artemis Mission Control. We just heard the crew call down to the team here in Houston, reporting that they have swapped out who is in the windows for the final portion of the lunar flyby. So Christina Cook is in window 1, with Jeremy Hansen in window 2 and Reed in window 3. Reed is focusing on observing corona, which is the solar corona, which is the sun's outermost atmosphere. There is about 18 minutes remaining in the eclipse period.
Science, and Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing.
Amazing. Thank you, Victor.
And just one more logistics note, we have gone as dark as we can in the cabin. We have turned the DUs all the way as dim as they can go, so you can't see anything on the screens. Every bit of light in the cabin affects the view. You're definitely seeing the brightness go closer. It's definitely brighter on the Earthshine side, and so we're expecting to see some corona here soon.
We copy all. Excited for what you see next.
I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but right off the well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet. That line of planets. There's something a moon diameter to the left, and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So. But anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window. And now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. It's quite a wicked view.
Victor,
Just doing the best job, and I'm not going to try to add on to what he's doing. It's indescribable. No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window.
this is just absolutely beautiful and inspiring to hear. And Victor, we suspect what you're seeing is Saturn and Mars. That reddish object is likely Mars. Good opportunity to look to the future of where we're going.
Yeah, we can absolutely see the color of Mars. That's awesome. Okay, and from this vantage point, the 4 o'clock on the Earthshine side is definitely getting brighter, still no coronal structure.
Houston copies.
And we aren't able to distinguish which Mare is, but we can clearly see Mare in the Earthshine.
We copy.
This is Artemis Mission Control in Houston, Texas.
We have not seen an impact flash in the last 5 minutes.
Sounds unlucky, but you had a pretty strong start, so we'll take it.
And actually, right after I said that, right at the South Pole, near the South Pole on the Terminator, Reed just saw one.
Amazing. Integrity Science, and as you look around our solar system neighborhood, you should see Saturn setting behind the moon right now.
We do. We've been watching it track close to the horizon, and it's right tangential to the moon at this moment.
This is Artemis Mission Control in Houston, Texas. We are currently 5 days, 2 hours, and 44 minutes into the Artemis 2 mission, and we have about 11 minutes remaining in the eclipse at the latter half of the lunar flyby that the Artemis 2 crew is experiencing on board the Orion spacecraft. We've received several different call downs from the crew and questions up from the science officer here in Mission Control. One of the things that they said that they were able to see is Mars off in the distance, and then the science team also confirmed that they should be seeing Saturn setting behind the moon. They've also acknowledged seeing several different impact flashes, and these are flashes of lights from meteorites striking the surface of the moon. They've also mentioned the solar corona, which is the sun's outermost atmosphere. Here in Mission Control Houston, the Orbit 1 and Orbit 2 teams have officially completed their handover. So the Orbit 2 team is now leading here in Mission Control, and that is being led by Flight Director Diane Daly, and the Capcom here in Mission Control will be Tess Caswell. And you can see there on your screen on the right-hand side is the Flight Director console, and Diane Daly is in the far right of that screen, and Tess Caswell, the Capcom or capsule communicator, is in the far left hand of that screen.
Okay, the light is continuing to grow in intensity. At about the 4 o'clock position on the, the 8 o'clock position on the Earth-shine side. Saturn has set. Mars is tracking towards the moon's horizon.
Integrity Science, we copy, and we're starting to see it on the vehicle stream. Looking forward to any coronal observations you can share with us.
This is Artemis Mission Control. That view you're seeing on your screen is coming from the solar array wing cameras outside of the Orion spacecraft. And you can see the light starting to come into view as the solar eclipse period is starting to end.
Integrity, still no coronal structure at this time, just continuing to grow in intensity.
Copy, Victor. And reminder, you still should have several minutes before the eclipse classes need to go on. And we can send you up a reminder when you're getting close to take your eyes away from the D5 viewfinder, but you should be good for several more minutes.
Copy, thank you, and yes, please send up the reminder. Thank you. Okay, we all think we're starting to see something. I believe the most popular term is baby hair. As the light grows in intensity and the horizon on this side becomes very distinct. You can still see Earth shine, even though the sun's brightness is definitely growing in intensity.
Love the description, Victor. I'm sure as the next couple minutes progress, more of those structures will continue to pop out.
This is Artemis Mission Control in Houston, Texas. The Artemis 2 astronauts on board the Orion spacecraft are currently observing an eclipse. And to the crew on board the spacecraft, the eclipse looks much like a total solar eclipse here on Earth, except the moon is much larger compared to the sun, unlike a terrestrial solar eclipse where the moon and the sun appear the same size in the sky.
We are definitely starting to see structure. That baby hair is rapidly growing out toward the 9 o'clock and the 8 o'clock. It's almost as if it were reaching out for Venus or for the Earth. If you've ever seen the spotlight off the top of the Luxor at night in Las Vegas, this looks like what that wants to be when it grows up.
Integrity Science, glad to hear you're following your training of tell it like you see it.
So far, it's pretty symmetrical. There are 2 or 3 streamers that are growing in intensity and in magnitude, and it's slowly starting to widen, starting to spread out across the horizon. Pretty amazing view.
And Integrity Houston, great words. Reminder for you, we are approaching the brightness level at which you should no longer be using the viewfinder on the D5.
Integrity copies, and thanks for the heads up.
This is Artemis Mission Control.
And I think we're seeing some directionality. Some of it is going in different directions because it appears to be moving and combining and recombining as it it's pointing in different directions, and some of it appears to be going like down toward the south pole of the moon, but it's and then coming back together and going out towards Venus and the Earth. And depending on how I stare at it, it looks like one large structure, but then it definitely has wisps, and you can see 3 or 4 structures inside of it. It's like watching a flame. It's like looking at a flame, and stand by. And so it has some inherent movement. Now there's a very bright spot. There's a very bright spot in the center of it. There's a towering light of and then there were like 2 streamers that were going 30 degrees out from it, and now it is just extremely bright.
Houston, copies all.
Starting to get a little warm.
And we copied all. We wanted to remind you at this point on the eclipse glasses. Should be about time for those.
Houston, we copy all. We are in eclipse glasses. That was an absolutely spectacular, magnificent experience.
Thanks for the report. We sure wish we were there with you.
This is Artemis Mission Control. The eclipse period is coming to an end, and we did hear that call up that the crew now has to put on those eclipse glasses to be able to protect their eyes for this final portion of the eclipse. And these views coming to you from the solar array wing cameras on the Orion spacecraft.
Houston, if you could give me about 20 new superlatives in the mission summary for tomorrow, that'll help my vocabulary out a bit. Thank you.
We will solicit input from the team.
This is Artemis Mission Control. There on your screen, you can see a live look inside of the SIR, or the Science Evaluation Room, here in Mission Control Houston, just down the hallway from the Artemis Flight Control Room.
Integrity Houston, back with you after a data rate change. Regarding the SAW-3 camera T low caution, no action for you. It just got a little cool during the eclipse.
Okay, we copy, and if you didn't copy my request for the mission summary to add about 20 new superlatives to help my vocabulary, I would appreciate it.
We copied it fantastically. And integrity science, this is basically wrapping up your fly-by-day observations. I can't say enough how much science we've already learned and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the moon closer for us today, and we cannot say thank you enough. And science signing off, and can't wait to talk to you tomorrow morning.
To your entire team, Kelsey, to the entire NASA science team, you all really turned to when we shifted launch dates to April 1st, and you got the most incredible package together for us to go do some great science and some great, truly human experience moments here. And we were well prepared, and we appreciate all of you. And this is what we do best when we all come together and work as a team. So you all knocked it out of the park. Thank you for giving us this opportunity.
Beautiful words, Reed. Thanks so much.
And this is Artemis Mission Control. The lunar flyby observation period is starting to come to a close following that eclipse. And there on your screen, you can see a look into the Science Evaluation Room, or the SIR, which is embedded within Mission Control to provide science input. And they provided that input throughout the live flyby operations today. They also have a back room called the Science Mission Operations Room that processes data, evaluates imagery, and supports rapid analysis. And then, of course, we have the science officer on console here in the Artemis Flight Control Room, which you can see a view there on the bottom right-hand corner of your screen. The science officer throughout the flyby operations today has been Kelsey Young, who is the Artemis Science Flight Operations Lead. And then to her left is Angela Garcia, who will be the science officer taking over for Orbit 2. And for the past 7 hours or so, the crew has been going through their lunar flyby observation period. And now they will wrap up that period and complete some final tasks and begin downlinking some of the amazing imagery that they've captured throughout the day, as well as some of the observations that they've recorded. And now on your screen, you're seeing a live look from the Orion spacecraft from those solar array wing cameras. The solar eclipse period ended just a few minutes ago, and during this eclipse, towards the end of the flyby window, it lasted about an hour, and it was when the sun was hidden from view behind the opposite side of the moon from the perspective of the Orion spacecraft and its crew. And during that time, the crew saw a mostly dark moon, and they used the opportunity to analyze the solar corona, which is the sun's outermost atmosphere, while it was visible. And then once the sun was completely out of view behind the moon, the crew looked for impact flashes, which they reported seeing multiple impact flashes, and those are flashes of light from meteoroids striking the surface of the moon. They also looked for dust lofting above the limb or the edge of the moon, along with some deep space targets, including planets, and they noticed Mars off to the distance, and we also saw Venus on one of the solar array wing cameras early on in the eclipse period. The crew also looked at parts of the moon illuminated by Earthshine, which is the sunlight reflected from the Earth when they come around toward the moon's near side at the very end of that flyby window.
Integrity Houston, understand that you are still reflecting upon and consolidating your lunar observations. At your convenience, I have 2 items related to the upcoming VIP event.
Go ahead.
All right, first we wanted to let you know that the message for that upcoming event is on board for review at your convenience. That's message 3.06.04. The second item is that we've seen a couple of video blips in previous events. So during the HDPAO setup activity, we're wondering if Jeremy could please confirm for us that the TS rate is set to 1300 when you get to step 10.
Okay, Jenny. Yeah, we're pretty sure we've been in 1300 for all the PAO events. We've been tracking that when we swap between the HHP and the D5.
We copy, Jeremy. Thanks. And for the record, the phenomenal Jenny has gone on to her next appointment of the day, and you've now got Tess with you.
I'm sorry, Tess. Great to have you on board Integrity.
No worries. Happy to be here.
This is Artemis Mission Control. We heard some communication there between the Capcom or capsule communicator here in Mission Control, which for Orbit 2 is Tess Caswell, and the CSA or Canadian Space Agency astronaut on board the Orion spacecraft, Jeremy Hansen. They were discussing an upcoming public affairs event.
And Integrity, 3-minute warning for the maneuver back to bias tail to sun.
The crew on board the Orion spacecraft recently completed their lunar observation period. It was an approximately 7-hour period of time in which they were focused on several different targets identified by the science team here on the ground that they studied and prepared for ahead of time. And then they also were referencing a lunar targeting package that was uplinked about a day ago with those final targets. Now they are completing some post-lunar flyby activities, so they're working to clean up their observations that they've made and also working to downlink some of the photos that they've taken throughout the day. The science team here on the ground will then work to get as much data as they can overnight, and then there will be a post-flyby conference tomorrow after the crew wakes up. And that's not a debrief, but a science data collection to capture their nuanced experience while they're still in the field and the experience is still fresh. And then, of course, there will also be a public affairs downlink event later in the day. Now that once the post-lunar flyby activities are complete, and then after that, the crew will go into some of their final activities for the day. They will have a private medical conference or PMC with the medical teams here on the ground. These are regular conferences that they have at the end of every day, and then there's also a flight director conference that they will have before they go into their pre-sleep period, during which they can complete hygiene activities and they will have the chance to eat their dinner and complete any other final personal activities for the day before they head into their sleep period.
if you're ready for us to start the stream a bit early and to test scene and voice.
Checking. And integrity affirm. We are go to start the stream.
Okay, Houston, the stream has started. We checked the TS rates 1300 and audio is true. So I will give you a voice check now on the mic.
We copy good settings and we've got a good view.
In test, I sent an audio check down on the handheld mic. Did you get it?
Sorry for the delay, Jeremy. We were talking that a bit, but it was a bit broken, so please repeat for us. Integrity Houston, we like the scene. At your convenience, we'll take a 10 count with Jeremy in frame.
Okay, copy that. Give us 2 minutes and or 1 minute and we'll do that.
Copy. Great voice check and good words. We like the scene. And Integrity Houston, we are seeing a black cable going right through the middle of the scene. At your convenience, if you would please move that, PAO would appreciate it.
This is Artemis Mission Control. We're currently 5 days, 3 hours, and 21 minutes into the Artemis 2 mission following a liftoff from NASA's Kennedy Space Center in Florida on Wednesday, April 1st. The crew on board the Orion spacecraft is currently wrapping up their lunar flyby cleanup activities. They're making final...
Houston Integrity, high priority PAO images from the eclipse are on PCD-1 in a so-named folder.
We copy, Christina. Thanks.
And NASA astronaut Christina Cook there calling down to the ground regarding some public affairs imagery that was captured during the lunar flyby activities. She referenced a PCD, that is in reference to their portable computing devices, which are basically tablets that they're able to transfer files and also follow along on processes and procedures and their timelines for the day. This is Artemis Mission Control in Houston, Texas. Currently on console here in Mission Control is the Orbit 2 team of flight controllers being led by Flight Director Diane Daly and the Capcom or Capsule Communicator, who serves as the single voice link up to the crew, is Tess Caswell. The crew on board the Orion spacecraft recently wrapped up their lunar flyby observation period, and now they are completing some cleanup activities and transferring some data and files down to the ground following that lunar flyby. Many of these files will be analyzed by the science team overnight in advance of a post-lunar flyby conference tomorrow once the crew wakes up. The crew is also preparing for an upcoming public affairs downlink event. And then following that downlink, they will have a few final activities for the day, including a private medical conference with their team here on the ground. These are standard conferences that happen at the end of every day, and they'll also have a private conference with the flight director here in Mission Control to go over the vehicle status and any other questions or concerns they may have for the remainder of their flight. We are currently in flight day 6, and we have a splashdown expected on Friday, April 10th. That splashdown expected in about 3 days, 21 hours, and 49 minutes from now. During the lunar flyby, and as part of Artemis 2, it marked the first time in more than 50 years that humans were able to observe the moon directly and provided a critical opportunity to practice how lunar science will be conducted during future Artemis missions. The moon preserves a near-continuous record of solar system history that has been erased on Earth, and with no atmosphere, weather, or plate tectonics, the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. Studying the moon helps scientists understand how planets formed and evolved, how the moon influenced Earth's history, and how the early sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. The science on Artemis is designed around questions best answered by humans working alongside robotic systems, combining decades of robotic lunar data with real-time human judgment, context, and adaptability. Currently on your screen, you're seeing a look at the Artemis Real-Time Orbit website. You can access this website at any time throughout the mission at nasa.gov/trackartemis. It provides updates on the velocity as well as the distance from Earth and the distance from the moon of the Orion spacecraft and its crew. The crew currently on board the Orion spacecraft includes NASA astronaut Reed Wiseman, who is the commander for the mission, NASA astronaut Victor Glover, who is the pilot, alongside the 2 mission specialists, who are Christina Cook and Jeremy Hansen of the Canadian Space Agency. Currently, the Orion spacecraft is about 250,000 miles away from the Earth, and that distance now will continue to close down ahead of that splashdown on April 10th. And they are now about 8,100 miles away from the moon, and that distance will continue to increase as they are now in the return leg of their journey.
Go ahead, Integrity.
Hey, Tess, great to talk to you. Any chance we could drop the fan speed down for this PAO event?
We will put that in work. Great to be talking to you, too.
This is Artemis Mission Control in Houston, Texas. We're currently 5 days, 3 hours, and 37 minutes into the Artemis 2 mission. The crew on board the Orion spacecraft has recently concluded their lunar observation period during the lunar flyby. As part of that lunar flyby, the Orion spacecraft and its crew made the closest approach to the moon at a distance of 4,067 miles away from the surface at approximately 6 p.m. Central Time, 7 p.m. Eastern Time. Now, although the Artemis 2 mission is a new opportunity to study the moon, teams are also conducting other scientific experiments, including on the crew themselves. Here's a little bit more about the science of the mission.
Artemis 2 is our return of humans to the moon, flying around the moon on board Orion. But along with that, we're doing a lot of great science.
One of the exciting things about the Artemis missions to the moon is that science is actually a fundamental pillar of why we explore, why we're going, what we're doing in Artemis.
I think it's incredibly exciting that not only are we testing the vehicle, but we're testing science on board. Science where the astronauts are conducting experiments, science riding along with the astronauts. We have astronauts looking outside the window and really observing the lunar surface.
It will help us understand the deep space environment. It will help us understand how that environment affects our astronauts, our systems, and life in general.
So deep space is a challenge for us because you have to leave Earth's protective magnetic field. Here in low Earth orbit, the crew members are protected from some of the harmful radiation. Going to the moon, they'll no longer be protected, so they'll have a higher radiation exposure.
Much like Artemis 1, we have so many radiation sensors and detectors that are inside the capsule so that we can fully understand and appreciate the radiation environment for protecting our astronauts. In my hand here, I'm holding a tissue chip model. This is the exact design that is going to be flying alongside the astronauts. We'll be collecting samples from each of the crew members, and we can make these organ chips out of the astronauts themselves. So every crew member will have their own avatar on board, and then upon return, we can evaluate that deep space radiation environment and what that compares to the astronaut themselves. Not only are they going to help change the course of medicine for the astronauts, but revolutionizing that on Earth as well.
We're looking at sleep, we're looking at team dynamics, we're looking at how you interact with the environment. We're also looking at the immune system, so what are the biomarkers? We're using saliva as a method to study hormones and different things in your body that may change during a mission like this. And then finally, how do we function after microgravity, being close to the moon, then returning to Earth?
Which will ultimately help us achieve our goal of getting humans to Mars.
And then on top of that, we have an opportunity to look at the moon from deep space on the far side for the first time in over 50 years.
How Getting human eyeballs and brains back around the moon is going to unlock a new generation of lunar science discovery. The human eyeball is capable of taking in so much data in just a split second. They'll be able to tackle impact history, volcanic history. They'll be able to look at how the albedo, or kind of the shade and hue of the moon and the color of the moon, can tell us something about how that terrain evolved over time. We're integrating science in ways that have never been integrated into human exploration before. We have a front room mission control flight controller position called the Science Officer. We have a brand new science back room where it's basically our brain trust of lunar scientists and geologists supporting the crews of the future. And Artemis 2 will allow us to really test how this works so that future missions are really set up for success.
We'll also be deploying some CubeSats. They're small shoebox-sized spacecraft of their own. They're each provided by another country, one of our partners. As they conduct their research, they'll complement what we are doing at the moon with Orion.
It is so incredibly exciting to be a part of this mission.
And it has been, really one of the privileges of a lifetime.
I can see the work I'm doing benefit crew members right now and benefit the crew members in the future. So it's incredibly exciting and it's very rewarding.
As this rocket launches humanity off of the Earth, we'll be setting the stage through our science to prepare humanity to leave Earth and explore the solar system.
And as part of that, we are going to inhibit cabin leak detection. The edge key manual response is still available. Copy, thumbs up.
This is Artemis Mission Control. Again, we're hearing some communication between the ground here and the Artemis Flight Control Room in Houston, Texas, specifically the Capcom or Capsule Communicator, who for Orbit 2 is Tess Caswell, and the crew on board the Orion spacecraft, that spacecraft named Integrity by its crew. They are preparing for an upcoming public affairs event, so they are discussing the camera views, which we will see here shortly. There on your screen on the left-hand side, you can see the Artemis Real-Time Orbit website, or ARO. The Artemis Real-Time Orbit website there on the left-hand side of your screen provides updates on the velocity of the Orion spacecraft during its journey around the moon. Following a lunar flyby earlier today, which concluded about an hour ago, the crew has been conducting some cleanup tasks, so they've been transferring some of their documentation, their photos and data that they captured during the flyby to the ground to be evaluated by the science team, and of course some of that imagery will also be evaluated by the public affairs team here at NASA and then shared with the world once it's available. The crew will also have a post-lunar flyby conference with the science team tomorrow following their sleep period to go over some of their observations while it's still fresh and at the top of their mind. On the bottom right-hand corner of your screen, you can see a look into the Artemis Flight Control Room here in Mission Control Houston, specifically the Flight Director Console and the Capcom or Capsule Communicator Console. The flight director currently on console for Orbit 2 is Diane Daly, and throughout the Artemis 2 mission, there are 3 shifts or orbits of flight controllers who provide 24/7 coverage and support to the Artemis 2 crew and the Orion spacecraft and its systems during its journey around the moon. We are expecting a splashdown on Friday, April 10th. That splashdown will take place in about 3 days, 21 hours, and 33 minutes. During the lunar flyby that took place earlier today, Orion, again that spacecraft named Integrity by its crew, passed approximately 4,000 to 6,000 miles from the moon and provided the crew with a full disk view of the lunar surface. And from that higher vantage point, much farther than Apollo's lunar orbits on average, the astronauts were able to observe both poles and large-scale geological features in a single view. And there on your screen, you're currently seeing a live look inside the cabin of the Orion spacecraft.
Integrity Houston, we are 3 minutes out from an on-time start, and we have adjusted the fan speed. We'll take a thumbs up if you're happy with it. Copy, thumbs up. Superlative thumbs up.
And there on your screen, you can see all of the Artemis II crew members. CSA astronaut Jeremy Hansen just floated out of view behind the camera, but you can still see NASA astronaut Reed Wiseman, NASA astronaut Christina Cook, and NASA astronaut Victor Glover as they prepare for an upcoming Public Affairs Downlink event, which is scheduled to take place in just a couple minutes from now. And there, floating back onto the screen, is CSA or Canadian Space Agency astronaut Jeremy Hansen. He is making himself comfy on some of the OX or Orion Crew Survival System suits that have been stowed for the outbound and now return journey. Shortly after the completion of these couple of public affairs downlink events, the crew will begin winding down for their day, and they will have the opportunity to eat dinner. Some of the items on their menu today for dinner include chicken with corn and black beans, sweet and sour pork, rice pilaf, spicy green beans, citrus fruit salad, and maple cream cookies. All of the And now we will go ahead and stand by for that public affairs event beginning in just about a minute.
Integrity Houston, no action for the DU-1. Caution, we're taking a look. Integrity, this is Houston. Are you ready for the event?
Hello, Houston. Integrity is ready for the event.
Administrator Isaacman, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, Jared Isaacman, comm check.
Administrator Isaacman, we've got you loud and clear, sir. How us?
I've got you loud and clear. Artemis II crew, we have a very special guest who wanted to be the first person to greet you after your return from the far side of the moon. Reed, Victor, Christina, and Jeremy, it's my honor to introduce the President of the United States of America, President Donald J. Trump. Over to you, sir.
Well, thank you very much, Jared, and you are doing a fantastic job. And hello, very special hello to Artemis II. Today you've made history and made all America really proud, incredibly proud. We have a lot of things to be proud of lately, but this is there's nothing like what you're doing, circling around the moon for the first time in more than a half a century. and breaking the all-time record for the farthest distance from planet Earth. Humans have really never seen anything quite like what you're doing in a manned spacecraft. It's really special. I want to personally salute and congratulate Commander Reed Weissman, Pilot Victor Glover, Mission Specialist Christina Koch, and Jeremy Hansen. And I also want to thank the entire amazing team at NASA, headed by Jared, who's a very special guy, by the way. And you all made this day possible, and you've really inspired the entire world. Really, everybody's watching. They find it incredible. I just watched you go to the back of the moon, and people haven't been there in a long time, we can say, but it's going to be more and more prevalent because we're going to be doing a lot of traveling, and then you're going to ultimately do the whole big trip to Mars, and that's going to be very exciting. So you look at, we had no astronaut has been to the moon since the days of Apollo program. The Apollo program was also very special, but that was 50 years ago, and at long last, America is back, and America is back in many ways stronger than ever before. We're the hottest country anywhere in the world. The Artemis crew flew in the most powerful rocket NASA has ever made, ever launched, traveled over 250,000 miles, broke the distance record set by the legendary Apollo 13. And America is a frontier nation, and the 4 brave astronauts of Artemis 2 are a modern day, you really are modern day pioneers, all of you, and one of them happens to be a neighbor. You know who that is, right? You have a special person over there, a neighbor, and we like our neighbor. Your mission paves the way for America's return to the lunar surface very soon. We're going all out. We're doing everything we can, and it's headed up by Jared. We'll plant our flag once again, and this time we won't just leave footprints. We'll establish a permanent presence on the moon, and we'll push on to Mars. That'll be very exciting. I'm waiting for that so much. I'd love to be here, but maybe we won't quite make it in terms of timing, but we will be up in the moon, and that's going to happen soon. So America will be second to none in space and everything else that we're doing, and we will continue to lead the whole thing into the stars, this incredible journey into the stars. So I just wanted, it's an honor to speak to you, and I wanted to congratulate each and every one of you. And tell me, what is the most unforgettable part of this really historic day? The whole world is watching and listening. Please tell me.
President, this call is certainly special to all of us, and we really have a lot of faith in our administrator, Jared Isaacman, who is with you. We appreciate his leadership in NASA and in the international community. We are doing great things, and we are proud to be a part of. I have to tell you, as we came around the near side of the moon, seeing all the sights that we've seen from Earth for all of our lives, but we're seeing them from a different perspective, and then we started to get a glimpse of the and we saw sights, Oriental sights that no human has ever seen before, not even in Apollo, and that was amazing for us. And then the surprise of the day, we just came out of an eclipse where the sun, moon, and the entire dark moon about that big right out the window that we were watching. We could see the corona of the sun, and then we could see the planet train line up, and at Mars, and all of us commented how excited we are to watch this nation and this planet become a 2-planet species.
That is fantastic. You know, I had a decision to make in my first term, and the decision is, what are we going to do at NASA? Are we going to have it be revived, or are we going to close it down? And I had very little hesitation, and it's really great to have somebody like Jared involved, because he really makes it much easier for me. But it was not even a question in my own mind. We've spent what we had to do, and then of course we have Space Force, and Space Force is very much related to what you're doing, and that was my baby. That was a very important one, and it'll turn out to be truly one of the most important, I believe, decisions I've ever made. So we're very proud of Space Force, and we're very proud of all of you. Does anybody else have anything to say? A lot of people listening.
Mr. President, to be here with you speaking about our incredible day today. I think one of the biggest highlights was coming back from the far side of the moon and having the first glimpses of planet Earth again after being out of communication for about 45 minutes. It really just reminds you what a special place we have and how important it is for our nation to lead and not follow in exploring deep space.
I'd like to ask, what was your feeling when you had no communication, zero communication? All of a sudden it was cut off by, obviously, your very special location. What was your feeling when you had no communication? A little bit different, perhaps.
Yes, Mr. President, it was cold. I said a little prayer, but then I had to keep rolling. I was actually recording scientific observations of the far side of the moon. You know, that is actually the time when we were the farthest and the closest to the moon. And so we were really able to make some of our most detailed observations of the far side of the moon up close. And so we were busy up here working really hard. And I must say, it was actually quite nice.
Did you see a difference, a big difference, between the far side of the moon and the near side of the moon? Was there a difference in feel or difference in look? What did you see?
Well, Mr. President, we certainly did, and our science team really set us up well to understand what they thought we might see. And the gravitational pull of the Earth has had a profound effect on the near side of the moon, changing all those dark mares, those dark patches of the moon you see from Earth. It's very different on the far side. While you see some small patches of those mare in deep craters, it's very much absent on that side, so that's really neat. And while I have the microphone, sir, I just want to thank you on behalf of Canada. The space leadership you spoke of from America truly is extraordinary. I've said this many times before. A nation that leads like that and creates and sets big goals for humanity that brings other countries along with it is truly incredible. And I know that's a very intentional, not a necessary decision, intentional decision to lead by example and to allow other countries like Canada to share our gifts and help you achieve these mutually beneficial goals, like establishing a presence on the moon and eventually going to Mars. And Canadians are so proud to be a part of this program.
Well, I have to say I spoke to a very special person, Wayne Gretzky, who I think you know, the great one. And I spoke to your Prime Minister and many other friends I have in Canada. They are so proud of you. And you have a lot of courage. I'm not sure if they'd want to do that. I'm not even sure if the great one would want to do that, to be honest with you. But you have a lot of courage doing what you're doing, a lot of bravery and a lot of genius. But they're very, very proud of you.
Administrator Alex, I'm going to just get a quick comm check, make sure you guys are still on the line and we didn't have a handover.
I am. Yes, I am.
And integrity, and back over to you, Mr. President.
Yeah, I think we might have gotten cut off. It is a long distance. It's a long ways. The reception's been great. There's a little bit of about a 9-second delay, but no, I just had a statement for, I don't know what you heard, but I was just saying they're very proud of your brilliant person from Canada on the ship. And Wayne Gretzky is a great friend of mine, and he's very proud of him. And the Prime Minister I spoke to, they're very, very honored that you have a courageous person from Canada. You have a lot of courageous people from Canada, so it was very nice. I'm not sure if you heard me say that, but it was very nice.
Yes, Mr. President, we heard that, and we do love our Jeremy Hansen. We love all our Canadian astronauts, Jenny Gibbons, Josh Kutrick. They're just great people, and they're such a welcome addition to our Corps.
Great. Well, I really look forward to, when we can, I look forward to seeing you in the Oval Office. I'll ask Jared to bring you over, and I'll ask for your autograph, because I don't really ask for autographs much, but you deserve that. You really are something. Everybody's talking about this. And I look forward to having you in the Oval Office at the White House, and we will celebrate your incredible achievements and triumphs. This is big. This is really big stuff. The whole world is talking about it. And if you have the time, I will certainly find the time. I've been pretty busy also, as you know, but I will absolutely find the time, and we'll get together, and I'm going to be giving you a big salute on behalf of the American people and beyond that.
Thank you for that, Mr. President. And when you want us, we will be there. And thank you for your leadership. Thank you to Jared for his leadership. Really, thank you for taking the time out today to visit NASA. It's really special for us, but it's really special for the team on the ground. A whole team of people all around the world pulled this off, and we just want to say thank you to all of you for this. It is the thrill and honor of a lifetime to have been on this journey. Today was amazing, but this 3-year journey has been amazing, and it was made possible by the American people and the Canadian people, and we're so grateful to you all. Thank you very much.
Well, thank you very much. And Jared, congratulations. We'll see you soon. And I know that you have Mars very much in your mind, so we'll start thinking about that pretty soon, I think. And thank you. Congratulations to everybody. I'll see you at the Oval Office.
Thank you for your time, Mr. President. It's been an honor.
Thank you very much. Bye.
Bye.
Integrity. This is Houston ACR. That concludes the event. Thank you.
Thank you to all participants. Integrity, we are now resuming operational audio communications. Integrity Houston, great job on the event. Just a heads up, we are on track to start the next event on time at 4:15.
Okay, sounds great. We'll be ready.
This is Artemis Mission Control in Houston, Texas. We just had that public affairs event with President Donald Trump and the crew on board the Orion spacecraft. And coming up in about 10 minutes, there will be another public affairs event. That event taking place at a mission elapsed time of 5 days, 4 hours, and 15 minutes. Currently on your screen, you're seeing a look at the Artemis Real-Time Orbit website, which provides updates on the velocity as well as the distance of the Orion spacecraft from both Earth and the Moon. The Orion spacecraft and its crew, that crew including Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, are currently about 250,000 miles away from the Earth, and that distance is starting to become smaller as they are now on the return leg of their journey. And they are about 9,300 miles away from the Moon. They made their close approach to the Moon.
Integrity Houston with a question about fan speed.
Go ahead.
Hey, Reed, we were wondering if this adjusted fan speed is something that you would like to keep going forward, or if it was just a specific change request for the events this evening.
Certainly for PAO events, this is an ideal fan speed. If you're willing to give us this fan speed for routine habitability, I think we would take it and try it for a while.
And Reed, we are able to support keeping the fan speed in this config. Happy to keep it here to collect data.
Okay, you got 4 happy astronauts up here. We'll take it. Obviously, when we go to exercise, we'll need to bump it up, but I think for quiescent living, this will be great.
We copy, and we love seeing those smiles.
config you're expecting. I have the dual camera bracket is installed, the window shade is closed, and the docking camera is stowed in its Alpha 3 storage area.
That's a good config.
Thank you.
And while I've got you, we are 3 minutes out from an on-time start of the next event.
This is Artemis Mission Control in Houston, Texas. You can see a live look of the Artemis 2 crew inside the Orion spacecraft cabin as they prepare for another Public Affairs Downlink event. There on your screen is CSA astronaut Jeremy Hansen along with NASA astronaut Reed Wiseman and NASA astronaut Victor Glover popping up. Earlier today, the crew completed their lunar flyby observation period, during which the Orion spacecraft and its crew passed approximately 4,000 to 6,000 miles from the moon and provided the astronauts with a full disk view of the lunar surface. And from that higher vantage point, the astronauts were able to observe both poles and large-scale geological features in a single view. Towards the tail end of that observation period, they also were able to see an eclipse. And that eclipse period lasted about an hour and was when the sun was hidden from view behind the opposite side of the moon from the perspective of Orion. Since then, the crew has been working to clean up some of their observations and transfer some of the data and imagery down to the ground to begin processing, and the science team will take a look at that imagery as it comes down ahead of a post-lunar flyby conference tomorrow with the crew following their sleep period. Now we are standing by for a second public affairs event taking place in about a minute.
Integrity, this is Houston. Are you ready for the event?
Houston, Integrity is ready for the event.
Administrator Isaacman, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, Jared Isaacman, ComCheck.
Administrator Isaacman, we've got you loud and clear up here.
I've got you loud and clear, and let's see if we can top that last PO event. That was pretty special. So we are going to spend the next 20 minutes doing Q&A from a number of questions that have been submitted, and we are going to start with one from me. You all have spent years preparing for this moment and imagining what it must be like when you look down at the moon, at the lunar surface. What has surprised you all that you did not anticipate?
Go ahead. No.
It's on.
Administrator, great to chat with you. Just something that just shocked me because really using imagery and just the three-dimensionality of it, you know from your experience of seeing the Earth from space, how it just seems different. And you look out in depth of things. And when we were on the far side of the moon looking back at Earth, it was just so obvious you had this sphere out in front of you of the moon and this three-dimensional. you really felt like you weren't in a capsule. You'd been transported to the far side of the moon, and it really just bent your mind. It was an extraordinary human experience. I'm so grateful for it.
Integrity, Jared, anyone else want to answer that one?
You know, we had an amazing launch. The SLS is quite a powerful rocket, and got us into a 1,200 by, eventually a 100-mile orbit, and clearly power and speed, and then we did our translunar injection, and we were going quite fast. And so with all of that speed, though, it still took us days to get here. And so the scope of all of the things to a 321-foot tall rocket was amazing. It just puts the power required to do this in perspective. But then even with all that power and to get to those velocities, it still took us days. And the breadth of the distance we had to cover. Watching the distance from Earth count up and the distance from the moon count down was one of the most surprising things I've enjoyed.
Well, as I was trying to formulate an answer, at first I couldn't think of anything because there are so many things to choose from. I'll try to just narrow it down, but I'm going to go with something we did yesterday, a manual power flight test objective, where we just basically got to sit at the vehicle. It was Jeremy and I this time, and just drive around using the rotational hand controller, basically just drive it with the stick, and how well it handled, how tight the control algorithms were, and watching it respond when we actually degraded it on purpose by going into 3 degrees of freedom control, by actually inhibiting some of the jets, which even though we have jet redundancy, of course, for each other in these complicated algorithms. So it was just amazing to be in a deep spacecraft and just be flying it around by hand. The one other thing I'll say, how fast it has gone by. I'm not ready to go home. I can't believe that something this cramped of quarters can fly by and still be fun every single minute.
And I'll just close out with, I think just scale, Jared, is the thing that is just blowing my mind. You flew Polaris Dawn to some amazing apogee numbers, and on the International Space Station, we're 250 nautical miles up, and that's the most beautiful view I think a human could ever experience. And we are dealing with numbers that are 250,000 miles, and every time Mission Control points this vehicle either at the moon or at Earth, and it reminds me every day that humans have to go, we've got to explore, we got to go further to expand our knowledge, expand our horizons. And every time we take another step forward, it makes the world seem a little bit smaller and a little bit more manageable. And just putting these numbers in perspective, it is impossible as a human to look at these displays and comprehend them. But here we are, and NASA is doing this, an international team is doing this, and they're doing it very well.
Excellent words, Integrity. So certainly a very wild insertion orbit. I can imagine the contrast between perigee and apogee, the scale of it all, the 3D, seeing the moon come alive, and then certainly manual control. Well, every Dragon crew for the last 5 years is very jealous on that. Okay, so we're going to questions here. This one, the Artemis II crew, inspire all of us, but what inspires you?
I think as you get older, your answer to that question changes a lot. Certainly when I was a young boy and a young man, just seeing an airplane flying overhead, to me, that really lit a fire in me. And then I think when you reach your middle age, it is interesting to watch leadership throughout the world kind of change the course of human. You can watch that unfold. And now that I'm just a little bit over 50, you'll be there soon. Now that I'm just a little bit over 50, I mean, it all ties back to just family, and you understand just how much the people that you surround yourself with, and that is really every night when you go to bed, that's really what you end up thinking. At least that's what I end up thinking.
Thank you. All right, so here's a question. It's a good one. So for the Artemis 3 crew, what is the advice you would pass along for the next astronauts that will go in Orion?
That's a great question, Jared. We've actually been thinking about the Artemis 3 crew since we were assigned as the Artemis 2 crew. It was the beginning of how we came up with how we wanted to fly this mission, how we wanted to buy down risk for the program, and values as a crew. And so, over the course of these 3 years, we've taken a lot of notes. So we've almost got a book to hand them. But I think a few practical things, just sitting here, we've been living for the past 6 days. How you pack is a huge impact to how you will live on the journey. And so things like food and your hygiene products, and then you know what's going on with our waste management system, the technology that we have, practicing that and being familiar with that and being prepared mentally. I used it on the space station. I used it at home in training. But I'll be honest, I wasn't really prepared to have to use it for over half the mission. And but we adapt and overcome. And so I can't wait to talk to that crew.
I'm glad you said it, or else I was. We definitely have to fix some of the plumbing. Okay, this question is from Merriam-Webster. So wordy one here. So you are going to be, you've already surpassed more than 250,000 miles from Earth, farther than any human has gone before. So what are some words that come to mind when you try to wrap your mind around this very unique experience?
I'll be honest with you, the main word, because superlatives just don't do it justice, is humility. We would never be here if it weren't for so many people that came before us, starting with Neil Armstrong, Katherine Johnson, Dorothy Vaughan, civil rights movement leaders, everyone who worked on this spacecraft. Before we got here in our 3 years of training, we went all over the country and even to our European and Canadian partners to see the people who have put their hands on this hardware, the millions of parts from every valve, to this entire thing, the people that put on harnesses every day to rig it up in the VAB. They all passed the record. We definitely didn't pass the record up here alone.
So this is actually very similar to the question the President of the United States asked just a brief bit ago. But during the quiet moments on your journey, when you were out of contact with everyone here on Earth, what were some of the thoughts that tended to occupy your mind most?
Yeah, as Victor said earlier, when we were on the far side of the moon and out of contact with planet Earth, we all knew it, and it was a milestone. We saw Earth disappear, the Earth set. But we were so busy with the science, and we have such faith in our vehicle integrity, such faith in mission control, that we were just at complete peace and just doing our job. And just trying to do a good job to collect as much science data as we could while we were on the far side of the moon, and we were just giddy in here, like of our lives.
He's being a bit humble, but as soon as we went out of comm with planet Earth, we did have maple cookies as we just gathered together for about 30 seconds. Each one of us had a maple cream cookie and then right back into the science. But we had to take a moment to honor that time going behind Earth, and it was going behind the moon and out of touch with Earth, and that was a very surreal moment for this crew.
Copy that. Good maple cookies on the far side. And how has this journey changed? How has this journey already changed the way you see our home planet and humanity's future among the stars?
There's so many directions I think we could go with that, and I just, I think that there's, global, but I think real impact is local, and is to see the Earth as an entire thing and look at it, this system, and to see it all in once. But my daughters, and just the things that we can impact directly, the people that I can touch, that I can speak to, hug, and show love and gratitude toward, is the thing that I think is going to change and last. And but you also talked about the future that we're going to have in the stars, and this mission, I think we swung for the fence and launched on our first try after learning a lot earlier this year. But I think it set the stage for us to go out and continue to swing for the fence hard in our Orion SLS and ground systems programs to go and get the next one teed up so that crew can knock it off out of the park. And so I have huge expectations for what's coming next.
Good words. Are you feeling homesick for Earth?
I will tell you, last of my eyes, I did start thinking about getting home. It's not homesickness at all, but the first time probably in 3 years, I let my mind get past the moon and back towards home, and I had to catch myself right there. You're an operator just like we are, and that is the place to be when you're up here. We got to look one step ahead. What's next? What's our next burn? How are we setting up our trajectory to get home? And we are going to do that. We are locked in, and we are definitely excited for the second half of this mission. And we are on guard. We are first crew to fly this vehicle. We are ready for any contingency in any scenario, and we are going to stay locked in every second until we are back on that Navy ship and then home reunited with our families.
And copy that. Astronauts like being in space. That checks out. Okay, there's a lot of questions from the space photography community. How are the pictures going so far?
Well, we all love getting our hands on cameras and our eyes behind the lens here, because we're just trying to share the incredible things that we're seeing, and that's obviously the best way we can try to do that. I've been into night sky photography for a long time, and so this is really a dream come true for me. I have thought specifically to that community, the time lapses I've been trying to get, those are a little tougher because we have a very dynamic vehicle. It's not like being on ISS where you can get the city lights below and the auroras and the spinning stars around the North Star. There's a lot going on. But what we got to matter is out of this world. When we viewed that eclipse, that was the one time we all said, we literally cannot capture this with a camera. Everything else, I think we've really put our hearts and minds into making sure we understand so that we can bring that home to everyone. But having to set the low light features for Earthshine on the moon while it's an eclipse, that was a new one. I had to dig deep in my book for that one.
And thanks for the iPhones. They've been working great.
Very glad to hear that. And there are a couple billion people back here on Earth that are extremely excited to look at the imagery you've captured up there. Okay, well, I want to thank you all. Integrity. So Reed, Victor, Christina, Jeremy, on behalf of NASA and space-loving people across the world, thank you for taking us with you to the moon. Thank you for your courage, all of your beautiful words that we've heard. You represent the absolute best of us. We are proud of you, and we look forward to welcoming you back safely to the good Earth very soon. Godspeed, and go Artemis 2.
Thank you so much, Administrator. We are just proud to be a part of this team, doing our work every day, and we are supported by a huge world
of humans, and we are just honored to be a part of that. Thank you.
We'll see you soon.
Integrity, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants. Integrity, we are now resuming operational audio comm.
This is Artemis Mission Control in Houston, Texas. That second public affairs event with NASA Administrator Isaacman and the crew on board the Orion spacecraft named Integrity now complete, and there on your screen you're seeing a live view from the Orion spacecraft, specifically from the camera on its solar array wings, and you can see a crescent Earth there. The crew is now officially on the return leg of their journey, and Earth is now their target, with that splashdown targeted for April 10th. This is Mission Control Houston inside the Artemis Flight Control Room as the lunar flyby coverage is coming to a close. You can see a final look there of the Orion spacecraft and that crescent moon in the distance. The Artemis 2 crew inside the Orion spacecraft named Integrity lifted off atop the Space Launch System rocket on Wednesday, April 1st from NASA's Kennedy Space Center in Florida. This crew is the first to live and work inside the Orion spacecraft. And about 25 hours after launch, Orion conducted its TLI, or translunar injection burn, which committed Orion to departing high Earth orbit and set us up for today's flyby. TLI also served as the spacecraft's deorbit burn as it slingshot Orion around the moon and set the crew on its free return trajectory, with that splashdown slated for Friday, April 10th. Last night, on flight day 5, the crew entered the lunar sphere of influence, the point at which the pull of the moon's gravity became stronger than the pull of Earth's gravity, and the crew will remain in this lunar sphere of influence until about 12:25 p.m. Central, 1:25 p.m. Eastern on April 7th. Today, the crew spent the majority of their day making science observations and capturing imagery as part of the lunar flyby, during which Orion and its crew passed approximately 4,000 to 6,000 miles from the moon and provided the crew with a full disk view of the lunar surface. From that higher vantage point, the crew was able to observe both poles and large-scale geologic features in a single view, and the Artemis 2 crew also became the first humans to directly observe certain far-side regions of the moon with unaided eyes. During the lunar flyby, the crew also surpassed the Apollo 13 distance record and made that farthest distance from the Earth during their mission at a distance of 252,756 miles away from Earth.
Integrity Houston, with 2 updates.
Houston, go ahead with the updates.
Hey, Victor, again, awesome job on both of those events. The team down here really enjoyed following along. I've got 2 sync items for you. The first is that based on ground schedules, we'd like to pull your Flight Director Conference up before your PMC, so we'll start the Flight Director Conference at the time the PMC is currently scheduled. And the second item is just following up on the DU-1 caution. We believe this is a recurrence of what we saw with DU-2 earlier in the mission. It's back up and it's ready for you to reconfigure displays as you wish, and I see you have that in work.
Okay, great. We would love a main and secondary dump line status, or really the main line.
Check in. And Reed, back with you on the dump lines. The main dump is open and it's proceeding very slowly, but the secondary is